Welcome to the FMC chapter of the HT32 MCU basic tutorial. This tutorial will introduce to you the HT32 MCU FMC function. We'll introduce this function from four aspects: FMC Introduction, FMC Registers, FMC Library, and FMC Library Application Example. FMC Introduction. FMC is the HT32 flash memory controller that provides functions of flash operation and prefetch buffer for the HT32 on-chip flash memory. Different MCUs have different features. The following takes the HT32 F52352 to introduce the HT32 FMC features. In the HT32 F52352, the flash memory consists of up to 4 KB block for bootloader and 128 KB main flash, of which 127.5 KB are used to store instruction or data, and 0.5 KB are used to store the option byte. If the main flash block is 64 KB, 63.5 KB are used to store instruction or data, and 0.5 KB are used to store the option byte. Note that the 4 KB block cannot be programmed or erased by the user. Therefore, the following description is for the main flash block. The 128 KB flash memory is divided equally into 256 pages, where each page is 512 bytes. So how does the FMC read from or write to the flash memory? To execute these operations, two critical functions are used: the word programming and the erase function. The word programming function is used to modify the flash memory content. The erase function is divided into page erase and mass erase. The page erase function can erase the specific page content. The mass erase function can erase the entire contents of the flash memory. What is the function of the option byte mentioned above? The option byte has two functions. One is the page erase or program protection function, and the other is the flash read protection function. The page erase or program protection function is used to prevent unexpected operation of the flash memory. The page protection function can be enabled for each page independently by setting the OBPP registers of the option byte. The flash read protection function is used to prevent illegal code or data access of the flash memory. This function is useful for protecting the software or firmware from the illegal users. The function is enabled by setting the OBCP register of the option byte. Then, we'll briefly introduce the FMC structure. FMC is slightly different for different HT32 MCUs. The left side of the block diagram shows the AHB peripheral bus and the system bus. The AHB peripheral bus is a high-speed bus interface that connects high-speed peripherals in the system to the CPU core, and is used for data transfer between the CPU and high-speed peripherals. The system bus connects the CPU to other lower-speed peripherals in the system, and is used for data transfer between the CPU and lower-speed peripherals. The AHB peripheral bus can configure and control the flash memory operations via the control registers. Since the access speed of flash memory is slower than the CPU, a wide access interface with a prefetch buffer is provided to the flash memory in order to reduce the wait state of the CPU. The middle of the block diagram shows the main internal structure of the FMC, including programming interface, control register, prefetch buffer, access interface, and so on. The control register part is used to configure and control the various operating parameters of the flash memory. The prefetch buffer part is used to reduce the wait state of the CPU. The wait state control part is used to manage the wait cycles during flash memory access. The addressing part is used to ensure that stored data can be correctly located and accessed. Data includes the data to be transmitted. The programming control part is used to program or erase the flash memory. The last part is the flash memory. As mentioned above, The top of this part shows the information block used to enable the loader and the bottom shows the main flash memory block. As we know, the HT32 MCU address ranges from hex 00000000 to hex FFFF, 4 GB. Different MCU addresses map to different areas, where the addresses from hex 00000000 to hex 1FFF correspond to the code area and are mapped to the flash memory. Option byte address map ranges from hex 1FF00000 to hex 1FF001FF. Block address map ranges from hex 1F000000 to hex 1F000FFF. As mentioned above, the flash memory consists of main flash block and information block. The 128 kilobyte main flash block is divided into 256 pages with 512 bytes per page. Here we can see that the option byte is located at the last page of main flash block. The physical address ranges from hex 0001 FE00 to hex 0001 FFFF, and the address map ranges from hex 1FF0 0000 to hex 1FF0 01FF. For each page located at the main flash block, if it is required to enable the page erase or program protection function, the corresponding OBPP registers of the option byte must be configured. If the OBCP register of the option byte is enabled, the flash security protection will be enabled. Information block address map ranges from hex 1F000000 to hex 1F000FFF. Information block stores the bootloader. This block cannot be programmed or erased by the user. Since the access speed of flash memory is slower than the CPU, FMC provides a prefetch register to reduce the CPU wait state. Then, we'll talk about how to set the FMC wait state. When the HCLK clock is greater than the access speed of flash memory, the wait state cycles must be inserted during the CPU fetch instructions or load data from flash memory. The wait state can be changed by setting WAIT bits of flash cache and prefetch control register, CFCR. If the HCLK clock is changed from lower to higher, change the wait state setting first and then change the HCLK clock. If the HCLK clock is changed from higher to lower, change the HCLK clock first and then change the wait state setting. The default wait state is 0 since the HSI with a frequency of 8 MHz is selected as the HCLK clock source after a system reset. The option byte has two functions, one is the page erase or program protection function, and the other is the flash read protection function, also known as security protection. These two functions can be enabled by configuring OBPP, OBCP and OBCK. OBPP is used to set the flash page erase or program protection. N in the OBPP N ranges from 0 to 127. When N is a value from 0 to 126, each OBPPN bit corresponds to 2 pages, i.e. page 0 to page 253. When N is equal to 127, it corresponds to only one page, i.e. page 254. If it is necessary to enable the page erase or program protection for the page from page 0 to page 254, the corresponding OBPP bit must be cleared to 0, and vice versa. For example, to enable the page erase or program protection for page 4 and page 5, the OBPP2 bit must be cleared to 0. OBCP is used to set the flash security protection and the option byte protection. The OBCP0 bit is used to set the security protection. Clear this bit to 0 to enable the protection. The OBCP1 bit is used to set the option byte protection. The last page of main flash, i.e. page 255, corresponds to the option byte. The option byte page protection is enabled or disabled by configuring the OBCP1 bit. OBCK is used to set the flash option byte checksum. OBCK should be set to the sum of 5 register contents when the OBPP or OBCP register content is not equal to hex FFFF. Here we'll talk about why it's necessary to set OBCK when the OBPP or OBCP register content is not equal to hex FFFF. Since the page erase or program protection and the security protection default to be disabled, that is, the reset values of OBPP and OBCP are hex FFFF. Either OBPP or OBCP is cleared to 0 to enable the corresponding protection function. Therefore, when the OBPP or OBCP register content is not equal to hex FFFF, it means that the page erase or program protection or the security protection may be enabled. It is necessary to set OBCK. The FMC page erase or program protection is used to prevent unexpected operation of flash memory. The page erase or word programming command will not be accepted by FMC on the protected pages. As you can see, for the operations of read, program, page erase and mass erase, after the page protection has been enabled, the access permission page is different for different modes, no matter ISP or IAP, ICP or debug mode, or from SRAM booting, the page erase and program operations are not available. Only read and mass erase operations are available. Note that the setting of page protection is based on page. The above access permission only affects the pages that enable the protection function. Other pages are not affected. The main flash page protection is configured by the OBPP registers of the option byte. The page ranges from page 0 to page 254. The last page of main flash is page 255, which corresponds to the option byte. The option byte page protection is configured by the OBCP 1-bit. The page erase on option byte area can disable the page protection of main flash. The page protection of option byte can only be disabled by a mass erase operation. The FMC security protection function is used to prevent illegal code or data access of flash memory and is useful for protecting the software or firmware from the illegal users. The security protection is enabled by clearing the option byte OBCP 0-bit to 0. Only the mass erase operation can be executed to disable the security protection function. For the operations of read, program, page erase and mass erase, once the security protection function has been enabled, all the main flash data access through ICP or debug mode, programming and page erase will not be allowed except the user application. Note that the user application means that the software is executed or booted from main flash memory with the JTAG or SW debugger being disconnected. But the option byte block and page 0 are still in protection and cannot be programmed or page erased. Mass erase operation can erase option byte block and disable security protection. FMC registers. Then, we'll briefly introduce the FMC registers. The flash target address register is used to set the target address of page erase and word programming operation. The flash write data register is used to set the data to be written for programming operation. The flash operation command register is used to set the flash operation commands. The flash operation control register is used to control the command commitment and check the status of the FMC operations. The flash operation interrupt relevant registers are used to enable or disable the FMC interrupt function and check the status of the FMC interrupt. The flash page erase or program protection status register is used to set the status of flash page erase or program protection. The flash security protection status register is used to set the status of the flash security protection. The flash vector mapping control register is used to control the mapping of vector. The flash manufacturer and device ID register is used to read the manufacturer ID and device part number information. The flash page relevant registers are used to set the page number and page size of flash memory. The flash cache and prefetch control register is used to control the cache and prefetch module of FMC. The custom ID registers are used to read the custom ID information. FMC Library. Holtec provides a standard peripheral firmware library including macros, functions and examples for peripherals. Using this library does not require users to have advanced knowledge of the HT32 MCU peripheral specifications, thus significantly reducing development costs. The following will introduce several FMC-related functions. The first function is used to set the vector remapping mode, i.e. the booting mode. The second function is used to erase the specific flash page. The third function is used to erase the option byte. The fourth function is used to erase the entire flash. The fifth function is used to execute the word programming function. The sixth function is used to configure the option byte. The seventh function is used to obtain the status of the option byte. The eighth function is used to enable or disable the specific flash operation interrupt. The ninth function is used to obtain the status of the flash operation interrupt. The 10th function is used to clear the specific interrupt flag of the flash operation. The 11th function is used to execute the wait state operation. FMC Library Application Example. Finally, we'll provide an application example to summarize this tutorial. This example is one of the standard peripheral firmware library examples. It should be used with the hardware starter kit. The program is used to erase the data in the specific page address, and then write the test data to the specified page address by using the word programming function, then compare the data in the specific flash address with the test data. Here are critical codes of this example. Before writing the data to flash memory, an erase function will be executed first. The flash erase function is used to erase the data in the specific page address, determining whether the erase is complete by obtaining the flash state after each erase, to check for errors. When the erase function has been completed, the flash program function is used to write data to the specified page address by using the word programming function, and also check whether the write operation is completed by determining the flash state. Finally, in order to ensure the accuracy of the data, the flash check function is used to read the data from the specific address and compare the data with the test data, to determine whether the flash data has been written correctly. Holtec has a professional service team to assist in the development, design, and after-sales service. Welcome to contact our business unit for more detailed product information and consulting services.